Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we're going to take a look at a geometric sequence, which is similar to the arithmetic sequence, except instead of adding a constant to each term, we multiply each term by a constant. Each term is equal to the preceding term multiplied by some non-zero constant that we label as R, the common ratio rather than the common difference. And to find the common ratio, we just divide some term by the term before it. The general term for these can be found by a sub 1 times r to the n minus 1. So the idea goes like this. The first term is a sub 1. The next term is r times a sub 1. The next term we multiply by another r, and so on. Oops, that should be a sub 1. So the third term has r squared, the fourth has r cubed, and in general, the nth term will have r to the n minus 1 power, the number of times that we're multiplying by r, starting with the first term of a sub 1. This will be missing by the time you see it. That's from a bad copy and paste. Problem 1. A person receives a gift on January 1st of $10. On the first day of each subsequent month, the amount of the person's gift doubles. So $10 on January 1st, $20 on February 1st, times 2. $40 on March 1st, times 2, and so on. Find the general term for the sequence and determine how much the person will receive on September 1st. So what we know is that the first gift was $10. And the common ratio is 2 because they double, get multiplied by 2 each time. So a sub n, the general term, we get from the formula a sub 1 times r to the n minus 1. And here, a sub n will be 10 times 2 to the n minus 1 power. September is the 9th month. So a sub 9 equals 10 times 2 to the 9 minus 1 power, or 10 times 2 to the 8th power. Let's go to the calculator for that. 10 times 2 raised to the 8th power. 2 to the 8th power is 256. Multiplying that by 10, we get $2,560. Now all we need to find is person that will give us those kind of gifts. Problem 2. Find a sub 6 and a sub n for the geometric sequence 3, 15, 75, 375, and so on. Well, if it is a geometric sequence, I know that a sub 1 is 3. 3 times 5 gives us 15. 15 times 5 is equal to 75. Multiply 75 by 5, it is 375. So it does follow that pattern. And now we can go ahead and find what we need. We know that A1 is equal to 3, and we know that R is equal to 5. So first, the general term, A sub n equals the first term, 3, times the ratio, 5, raised to the n minus 1 power. And A sub 6 would equal 3 times 5 to the 6 minus 1 power, or 3 times 5 to the 5th power. 3 times 5 raised to the 5th power, that's 9,375. Find the first 5 terms of the geometric sequence with a sub 1 equals 4. The iPad will catch up in a sec. There we go. And r equals 1/2. And then we want to find a formula for the general term. So the first term is 4. Multiply 4 by 1/2. That next term is 2. Multiply 2 by 1/2. That next term is 1. 1 times 1/2 is 1/2. And then finally, 1/2 times 1/2 is 1/4. So there's the first 5 terms of that sequence. we can see where that's going, right? That's going to converge to 0. Each time it's half the size, but it's still going to stay positive. So eventually it approaches 0. The general term, again, we've got A1 equals 4. We've got R equals 1/2. A sub n equals A sub 1 times R to the n minus 1. And in this particular case, that's 4 times 1/2 to the n minus 1. One last problem with geometric sequences, we want to find A sub 1 and R, the first term, and the common ratio, if we know that A sub 4 equals 40 and A sub 7 equals 320. To go from the fourth element of the sequence to the seventh, that's three members away. So we know that A sub 4 times the common ratio 3 times, or R cubed, equals A sub 7. 40R cubed equals 320. Divide by 40, we get R cubed equals 8. Take the cube root of both sides and we get that R is equal to 2. So we've got the common ratio as 2. What we now have to figure out is what is the first term. Well, we do know that A sub 4 is equal to, by the formula, A sub 1 times R to the 4 minus 1 power, or third power. So 40 would equal A sub 1 times 2 cubed. And 2 cubed is 8, so if we divide both sides of this equation by 8, we get that A sub 1 equals 5. And once we know A sub 1 and R, there are a lot of other things that we can do with a geometric sequence, and we'll talk about those in an upcoming video.